Hey guys! In this presentation, I'm going to be talking about dark matter. Dark matter is basically anything that interacts with visible matter through gravity, but that we can't detect through normal electromagnetic radiation. One of the reasons that I decided to choose this as my subject was because I thought it was really interesting that we've known about its existence for literal decades, but scientists still seem to have no idea what it's made up of or what it is. All we know is basically that it exists. It's especially crazy to think that, because of the existence of dark matter and dark energy, we don't know what makes up about 95% of the universe. And I thought that was cool because it really shows you how much scientists have left to discover. So in the video, I'm going to be talking about what dark matter is, discuss a little bit of the history behind it, tell you guys how we know it exists, and then talk about a few theories we have as to what it might be. So here we go, let's start. So first we're going to go a little bit into the history of dark matter. Its existence was theorized as early as 1922 by this dude right here, Jacobus Kapteyn. And then this other guy right here, Fritz Zwicky, had a similar theory, and he was actually able to calculate that the majority of matter was dark as early as 1933. What he did this by looking at the speed of solar systems as they traveled around their galaxy and determining the amount of mass that they must have required to be going at that speed. Even though it's been about 100 years, we still don't really know much more about dark matter than what these people discovered, but we definitely know that it exists now for a few reasons that I am going to tell you about. So the first reason that we know for sure that dark matter exists is because of galaxy rotation curves. As we all know, galaxies rotate very fast. I will demonstrate using a graphic. There we go. So a lot of scientists noticed that the galaxies were moving way too fast for the amount of matter that you could physically see. Like we learned in physics class, the further away you get from something, the less gravitational pull it will have on that object. So for example, solar systems around the edge of the galaxy should have been orbiting at a slower speed than solar systems in the middle of the galaxy. But that wasn't really the case. As you can kind of see on this diagram down here, as the solar systems got further away from the center of the galaxy, they should have been going at this calculated speed in red right here, which means that they should have been kind of slowing down as they got further away, but they actually kind of maintained the same speed as shown by the actual data that was measured. And this wouldn't be possible at all unless the galaxy had a lot more matter than was originally thought. So the only explanation for this that doesn't involve breaking several laws of physics is that that dark matter has to be real to account for all of this matter that the galaxy apparently has, but that we can't see. But now we know that galaxies wouldn't even have formed in the first place if it weren't for dark matter. Alright, so another way that we're actually able to measure dark matter and that we know it exists is through gravitational lensing. Gravitational lensing is basically what occurs when an object or galaxy has so much mass that it's able to kind of bend and distort light as an object passes by. So for example, in the picture, you can kind of see gravitational lensing occur right here. You can see this bubble that's kind of the distorted light as the object is passing by. And this much gravitational lensing wouldn't really be able to occur unless the object had a lot more mass than we could actually see or detect. So by knowing how much mass is required to create this kind of gravitational lensing, we can measure the amount of dark matter that's in a specific area by looking at how much the light kind of distorts on it.